Unit 2.1, Operations on Radicals. Today we are going to add, subtract, and multiply radicals. We are going to divide radicals involving binomial-like radical expressions. To add or subtract radicals, do as you would with like terms. Example number 1, simplify. So in example number 1, we are going to distribute a negative 1 to both of these terms. So our first parenthesis, 3 root 3 minus root 2 is going to stay the same. Distribute a negative, we get negative 5 root 3. Negative times a negative gives us a positive 6 root 2. We then need to combine our like terms. So negative root 2 plus 6 root 2 gives us 5 root 2. And 3 roots of 3 minus 5 roots of 3 gives us a negative 2 root 3. We cannot simplify any further. When we're simplifying in example 2, we need to make sure that our radicals are simplified completely. So when we simplify 3 roots of 8, if you make your factor tree, take out your perfect root, you get 6 root 2. To simplify 4 roots of 18, it simplifies to 12 root 2. And to simplify the square root of 50, you get negative 5 roots of 2. After you've simplified all of your radicals, you then can combine your like terms. So 6 root 2 plus 12 root 2 is 18 roots of 2, minus 5 roots of 2 gives you 13 root 2. Example number 3 is multiplication, so we are going to multiply the binomial by the square root of 2. We're going to multiply whatever's underneath the radical by whatever's underneath the radical in both terms. Whatever's on the outside, which is an invisible 1, we would multiply by what's on the outside of our radicals. So 1 times 7 is 7. Square root of 2 times square root of 2 is square root of 4. 1 times negative 6 is negative 6. Square root of 2 times square root of 3 is square root of 6. Simplify square root of 4, we get 7 times 2, which gives us 14, minus 6 root 6. We can't combine anything any further. We're finished. When we distribute in example 4, 2 times 7 is 14. Root 2 times root 2 gives us a root 4. 2 times negative 6 gives us a negative 12. Root 2 times root 3 gives us a root 6. 4 root 6 times 7 root 2 gives us positive 28 roots of 12. And then 4 root 6 times negative 6 root 3 gives us negative 24 root 18. We need to make sure it's simplified completely, so we need to reduce any perfect squares. So 14 times 2 minus 12 roots of 6 is simplified. 6 times 2, 3 and 2, 28 root 12 reduces to positive 28 times 2 roots of 3 minus, when we factor 18, we can pull out a 3. We're left with a 2 underneath our radical. 14 times 2 is 28, minus 12 roots of 6. 28 times 2 is positive 56 roots of 3, minus 72 roots of 2. None of these are like radicals, so we are finished. Example number 5, it's extremely important when we have something squared that we write that out 2 times in order to not lose our center terms when we distribute. 6 times 6 gives us 36. 6 times negative 2 root 5 gives us negative 12 roots of 5. 6 times negative 2 root 5 gives us negative 12 roots of 5. And negative 2 root 5 times negative 2 root 5 gives us positive 4 root 25. Combined our like terms, negative 24 roots of 5 plus 4 times 5 is 20. 36 plus 20 simplifies to 56 minus 24 roots of 5. Recall that expressions in simplest form cannot have square roots in the denominator. When there is a sum or a difference involving a radical, we rationalize the denominator by multiplying the numerator and the denominator by the conjugate of the denominator. So when we look at these examples, if we have negative 8 root 3 plus 4 root 11, the conjugate is negative 8 root 3 minus 4 root 11. If we look at this second little example right here, if we have 2 root 2 minus root 3, the conjugate, notice this sign in front of your second term changes, is 2 root 2 plus root 3. This sign out front will always remain the same. It's only the sign in between that changes. So example 6 says state the conjugate. So our 11 roots of 2 is going to stay the same. We're going to change our sign to a plus instead of a minus. Root 5, and we just wrote the conjugate. Example 7 says multiply 12 plus root 7 by its conjugate. So 12 plus root 7. The conjugate would be 12 minus root 7. And if we distribute this out, 12 times 12 is 144. 12 times negative root 7 is negative 12 roots of 7. 7 times positive 12 is 12 roots of 7. And square root of 7 times the square root of 7 gives us negative square root of 49, which simplifies to 7. These center terms cancel out. So if we have 144 minus 7, we get 137. So remember, we cannot have a radical in the denominator. So when we rationalize and use the conjugate, we will always end up with a nice, neat whole number. Example number 8 says rationalize the denominator. So we need to get the radical out of the denominator. In order to do that, we need to multiply by the conjugate. So the conjugate would be 5 plus radical 3, 5 plus root 3. When we distribute our top, 2 times 5 gives us 10. 2 times root 3 gives us positive 2 roots of 3. In the denominator, 5 times 5 is 25. 5 times root 3 is plus 5 roots of 3. Negative root 3 times 5 is negative 5 roots of 3. Negative root 3 times positive root 3 is negative root 9. 10 plus 2 root 3 in the numerator. 25 minus 3 in the denominator simplifies to 10 plus 2 roots of 3 in the numerator. 25 minus 3 gives us 22 in the denominator. In order to simplify these three numbers on the outside, it must form a heart. 10, 2, and 22 are all divisible by 2. So 10 divided by 2 reduces to 5. 2 divided by 2 reduces to 1. We don't touch anything underneath our radical, and 22 divided by 2 is 11. So our most simplified answer is 5 plus 1 root 3 over 11. Example number 9, if we rationalize the denominator, we multiply by the conjugate, which is 4 minus root 2. Whatever you do to the bottom, you must do to the top. So 2 times 4 gives us 8. 2 times negative root 2 gives us negative 2 root 2. Negative root 5 times 4 gives us negative 4 root 5. Negative root 5 times negative root 2 gives us positive root 10 in the numerator. When we distribute out the denominator, 4 times 4 is 16. 4 times negative root 2 is negative 4 roots of 2. 4 times positive root 2 is plus 4 roots of 2. Root 2 times negative root 2 is negative root 4. We need to combine our like terms. In the numerator, nothing combines. All of our radicals are simplified, and none of them are like terms. In our denominator, we can see negative root 2 plus 4 root 2 cancels out. Square root of 4 is a whole 2. 16 minus 2 gives us 14 in the denominator. And we are finished. 8 minus 2 root 2 minus 4 root 5 plus root 10 over 14 is the most we can simplify. Please do not make the mistake and try to reduce this 8, this 2, this 4, and 14, because this 1 right here is not divisible by the same things. So we are in fact finished.